Hello, everyone. Give us a thumbs up if you can hear me. We are here today for another session of community conversations for Technomatics plant simulation. My name is Taryn Blake. I'm the Community Engagement Program Manager for the PLM Community Forums here at Siemens. And today our topic is collision control basics with free moving AGVs. I'm very happy to present another one of our community catalysts. Normally Stefan's with us, but Alex Dilg has been a community catalyst for quite some time, and he is an expert with nearly 15 years of experience in simulation for plant simulation. So Alex has been a consultant at Simplan AG. During that time, he specializes in simulation projects, support and training using Technomatics plant simulation. His project focus includes intralogistics, covering both conveyor systems and vehicles, as well as library development for VDA and Simplan. So our agenda, three big points today for the agenda, which are using the distance control template to prevent collisions or collusions, and then resolving deadlocks with planned collisions and preventing deadlocks with planned collisions. So as always, we are live. Alex will be presenting live in the software, and we will conclude with a live Q&A. So you will be able to raise your hand using the function that should be in the middle upper menu on your screen with a hand raise button, and we'll be happy to take you off mute so that you can ask questions. And as you can probably see, the chat is also available throughout the presentation. So we will attempt to get to all of the questions as we go through, but that's all for me and the introduction right now. Alex, feel free to take the screen and begin.
Okay, thank you, Taryn. I hope you can hear me and you can see my screen. Please, no complaints. Good. So we are talking about collision control for the free moving AGVs today. If you, I hope you saw in the invitation and in the post in the forum the reference to the previous session that Stefan did in December, where he introduced the basics about free moving AGVs in plant simulation. So we will assume that you have that knowledge at least available. And today, so we will look at the collision control and or the distance control for managing collisions. This is a huge topic where you could spend like days coaching or building controls depending on the level of detail that you need for your specific model. So this will be really very basic stuff to get you started. But of course, I will be open, or also Stefan, to do a follow-up session to delve a little deeper into this topic. Also, part of the invitation and of the post was a starting model, which you can download if you want to follow along. Technically, you could also follow along in a completely empty model or in a model of your own. But I'm going to use this starting model simply so we don't spend time for creating a layout and having vehicles drive around, because that is the basic knowledge that we will assume you already have from the last session. One more note in general about the starting model or the things that I will show you today. I'm using Plant Simulation version 2404, so the current version. I have uploaded the starting model as well in the previous version 2302. You can basically do the things also with that version. There are some differences in the model that I show, or in the things that I will do. So just in case you are using the previous version, the differences are that I'm using a default curve radius of 0 for the AGVs. That means that in the latest version, the AGV will rotate on the spot if it has to change direction, and it will take into account the rotation speed. So this will consume time to rotate 90 degrees to the right and then continue driving. If you use the old version, the AGV will kind of instantaneously flip 90 degrees and then continue traveling. The safety zones, which we will be using here, can be displayed out of the box in the latest version. In the previous version, if you want to visualize the safety zones, you will have to create some graphics for that yourself. Also, the last point, I've used some user attributes on the AGVs in this model that I'm displaying in 3D. This is a function that is also not available in the previous version, but this is simply for visualization, so this is not relevant for the logic itself. The only really important difference is that the stopping counter attribute, which was introduced in the previous version, was not yet watchable. So you cannot observe or wait until this one changes. This is something I will be using here in the model. If you try to follow along in the older version, you would basically have to create your own attribute, like a user-defined attribute, which you can then watch. But we can also talk about this after the session if you have a question about this. Good. Then to first introduce this starting model that we have here. We have a layout of markers which are connected with connectors, and I have 5 AGVs that are happily randomly driving around the layout, as you can see. And as you can also see, they are colliding and driving through each other all the time whenever they meet at intersections, or when one of them stops and the one behind doesn't want to stop, it just drives right through. So this is kind of the problem setting that we have. If you start using the free moving AGVs, this is probably what you will have realized quickly, that this is what's happening, and we want to talk about some basics of how to prevent this from happening. This model comprises of basically 3 methods and a table. This table is simply a list of all the marker objects in the layout, and I'm using this table to randomly pick one of all these markers to let the AGV drive there, and then I pick another marker randomly to drive there, and so the AGVs keep driving randomly through the layout here, just so that I have a continuous movement here without having specific orders or stations or transports, which is not relevant for the actual collision control topic. So the starting model starts with the init method, which I can zoom in a bit here in case this is too small for you. I can also hold away some of this stuff that we don't need. So the init method simply walks through all the AGVs that are registered in the pool, and basically it calls the method AGV control for each AGV. And then it waits 15 seconds, it calls the method again for the second AGV, then for the third, the fourth, the fifth. This is simply to prevent all the AGVs from leaving at the same time, and then kind of all of them moving through each other, reaching the first marker at the same time. So I just wanted to have a initial delay for the AGVs when they start driving. And then the AGV control method is in some similar form, something that you will probably have if you work with the free moving AGVs. Basically here, I'm choosing one of the markers from the list randomly, and then I say, this is your new destination, so go and drive there. I wait until the AGV has arrived, I wait 5 seconds, so I stop there for 5 seconds, and then I repeat the process, choose a new random destination, drive there, wait 5 seconds, repeat, 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 and I'm doing this for each AGV. Right, and then I have a arrival control for the marker, but I'm currently not doing anything in here. So this is the setup where we start here, and right. So what you're seeing in the 2404 version are the safety zones of the AGVs. So this is what I meant with they can be visualized out of the box. You see the orange and the red zone that's kind of preceding the AGVs. These are the built-in safety zones. So when we look at one AGV, you have these settings on the controls tab where you can define the zone 1 and the zone 2. You can define the length and the width. And you can see that I have defined like the inner zone. The zone 1 is the red one, and the orange one is the zone 2. So this is kind of a outer zone is kind of a pre-alert that something is coming close. So we might want to do something, and then the red zone is kind of it's getting really close. We might have to stop or like take an emergency break or something. So what might be confusing, or what you might have expected if you've already looked into this topic, and then you found these settings and you activated them, and then you see these zones being displayed as we have here, you might have expected that they automatically have an actual effect, which is obviously not the case. So this is they are only defined, their size is defined, and I'm visualizing them, but we have not any kind of default functionality that automatically comes when you say the zone 1 is a half meter or something. So for that, we have to use this distance control, which we will look at now. So let me reset this one here. I will duplicate the model for these different steps so that when later you download the finished model, you kind of have like the step-by-step models that you can still refer to. So here I will have a first model, and I will call it distance control. You don't have to do this. If you try to follow along, you can just do it in the one model and keep modifying it. That's completely optional. I'll remove these things that I'm not using here. I will also duplicate now my AGV class here and say this is AGV distance control, or say template. When we go into this AGV class, you have on the controls tab, you have these zone settings, which I have already prepared in this model. And you here can define various control methods. The one that we are interested in here is actually the distance control. And you can create a control here by using create control or by pressing F4. As you probably know from other objects, if you do this in plant simulation, you may get a method that is filled with some template code or default code to help you get started. So you will have something similar when you're using a pull control, for example. And so this is the template code for the distance control, which is a little, or I think it's probably the biggest method template that we have in plant simulation. I think at least I can't think of a more complex one on the top of my head. So if we assume that you have no big previous experience with this, so we will first explain this this default code of the method, so what it is doing, and then later we will modify it for our use case. So this template code has some points that are not really relevant for our scenario here. So I will duplicate this again and call it clean up or something. Go here and go into this method and remove some parts that are not relevant for this kind of model that we are using here. So first you see that you have two different sets of parameters for this method or arguments. The second one, which is inactive by the comment, this one would be used if you have track-bound vehicles. So the transporters are driving on tracks, not free-moving as we have here. So we want to use the safety zones for the free-moving AGVs. That's why we need these parameters. And this one here we don't need, so I will remove it because then the method is a little cleaner and we don't get confused by it. Similarly, this first if condition that we have in the method checks whether we are a free-moving AGV or not. So for free-moving AGVs, the AGV pool attribute is set. If you are track-bound, then this one is not set. Because we are only using free-moving AGVs in this model, we can also remove this condition here and have our method a little more compact already now. So the two parameters you get is first the Boolean that tells you, did somebody else enter or leave one of my safety zones? So this method, you always have to think of it as like from the point of view of one AGV. So this method is called and it tells you, did some other AGV enter or leave one of your safety zones, and did it happen to zone number 1 or 2? So the first code block then looks at the case that something happened in your inner safety zone, which is the smaller red safety zone. So this is usually the situation where we say we take, or this is what template code is doing, is like doing an emergency brake, stopping this AGV and basically waiting for the problem to dissolve or to disappear. So if something happens in the zone number 1, then we request, or we get the number of other different AGVs in my safety zone number 1, so in my inner safety zone. And and then this code block here says if somebody entered my zone and if num_mu in zone 1 is now 1. So this in combination means that another vehicle entered my inner safety zone and it was the first one. So at this point, I, as the AGV for which this control is called, I have to stop. This is being done by incrementing the stopping counter attribute here by 1. So as soon as this attribute is not 0, free-moving AGVs have to stop. They will, if that is activated, they will consider deceleration to reach a speed of 0, so to come to a stop. And basically, you could also increment this stopping counter for other reasons. So you could use it in other controls to say the stopping counter is incremented by 1 through this distance control, but you could have other reasons to say there is another reason to stop a failure or battery or some other collision control method that has nothing to do with other AGVs. So, for example, you have to also consider collisions or prevent collisions with workers, or probably that would be the next best case. So as long as the stopping counter is greater than 0, the AGV has to stop. So, and then the other case is if inside zone is false, that means that somebody has left my inner safety zone. And then similarly, we wait until there is no other AGV in my inner safety zone. And at that point, we decrement the stopping counter by 1 again. So in this scenario here, we will only ever have the value 0 or 1 for the stopping counter. But as I said, technically you could increment it for other reasons and have a stopping counter of 2, 3, 4, whatever. Okay, so keep it like this. So the first block is about the inner safety zone, and then this following block is basically about what is happening in my outer safety zone. So do I already know that there are some other AGVs close by? So they have entered this orange zone. So again, similarly, I request how many vehicles are in my outer safety zone. If there are any, then this code reduces my speed to 70% in this template. So in case that there's also somebody in my inner zone, this stopping counter is incremented. So as long as that is greater than 0, I cannot move, no matter what speed you set. But assuming that this one is 0, down here we will set 70% speed limit. While any other AGV is in my outer safety zone. And if numMu in zone 2 is not greater 0, that means it's 0. So that means there is no other AGV. Then we can restore the maximum driving speed. So this is basically what is happening in this method template or standard code. So we will now take this AGV, assign it to this AGV pool, and let the simulation run. And then we will have to wait for some situations where the AGVs cross their safety zones. And if you look closely at these points where they're getting close, you saw that some of them briefly stopped and let the other one pass, and then they resumed moving. So depending on the actual layout that you have and the movements that your AGVs take. So here you see this one stopped and it let the other one pass. And then here again, this one stopped and let the other one pass. So depending on your actual layout, this method template for the distance control may be enough to already prevent collisions and having your model run without unrealistic behavior and enabling you to conduct your experiments. But as you see in this example model, after a few minutes, we have a situation like a deadlock situation here, where the AGV1 and the AGV5. So if I zoom in here, you will see the two red zones. So you will see that at the same time, AGV1 is in the inner safety zone of AGV5. and vice versa. So both of them are basically stopping and waiting for the other one to get out of the way. So if you have these kind of heads-on collisions, and they can happen in your model, then this is a typical scenario where the default method template will not be sufficient. Good. So the second step that we wanted to look at is I kind of called it like resolving the deadlock. So again, here for me, I will duplicate the model and the AGV class. So we will now modify this distance control to, in case of one of these deadlocks occurring, we will simply resolve the deadlock by allowing the AGVs to drive through each other in that specific situation. So most of the time for like the normal or easy collisions, this control works, the AGVs will stop, but we want to catch this this specific case where they run into a deadlock that will never end and your model is basically dead. So for this, I will realign the code here a little bit. So first, as normal, we increment the stopping counter. So this means that we have now stopped. But what I want to do now is to say, if I am stopped for a long, let's say a long time, this means a deadlock has happened. So in that case, I want to allow the AGV to just resume moving again, so that this kind of deadlock situation can be resolved. To do that in the latest version, I can simply use wait until the stopping counter is 0. And then I will add a timeout of 30 seconds. So I will not go into too many details here regarding these SymTalk functions, but in case you don't know anything about them, this does what it reads like when you just read it from left to right. So we wait until a certain condition is met. So the stopping counter of the AGV has reached 0 again. And we have a maximum wait time of 30 seconds. So after 30 seconds, I will assume that the deadlock has occurred. This wait until statement means that the method execution is kind of paused or suspended until either the stopping counter is 0 or until we have waited for 30 seconds without that being the case. I can then ask which of the two situations has happened. So was the stopping counter reduced or have we waited too long, by querying wait expired. So if wait expired is true, that means this is a deadlock. And we simply, let's do it properly. We decrement the stopping counter again by 1. This means the AGV is allowed to resume moving. And that's basically it. So now the AGV after 30 seconds will be allowed to resume moving. We will have one more thing to change here, because now we have decremented the stopping counter to 0 already. So I resume moving, I move away, and that means that at some point the other AGV will no longer be in my way. So we will run into this situation here at some point later, but we must not decrement this counter again. So for that reason here, I will add the condition is also the stopping counter still greater than 0 to prevent me from like counting it down twice. And then I will put a breakpoint in here and use my new AGV class. Set the speed 10 times and let it run. And then in this corner here, you will remember there was the place where we had the collision between, I think, AGVs 5 and 1. So here they come, and now they are locked. And the simulation is now running for 30 seconds. So I have a speed factor of 10. So 30 seconds have passed. You can see that wait expired is true. We are now decrementing this counter to 0. That means that the AGV is now allowed to continue moving. So you see the AGV 5 and 1, they resumed moving again. There was a little bit of an actual collision, if you look closely, but that's what I meant with we are accepting that for the purpose of the simulation. Because in many cases, when you run a simulation model, you always have to remember that you should choose a level of detail or of that is reasonable for what you are investigating. So your model should be as accurate as necessary, but as inaccurate or as simple as possible. So this would be a really good approach, especially if you're a beginner, to simply say, okay, I'm avoiding most of the collisions. If I have one of these like nasty ones, I allow them to be resolved by maybe having a collision. If you know that in reality the AGVs have some way of like navigating around each other to resolve such situations, there is absolutely no need to model this kind of movement in detail in the software. This is a lot of work, and the main reason to do this is to have a nicer animation. So typically we would say we don't do this. We would of course count how often does this happen, that we have a kind of a collision where we allow the AGVs to move through each other. And if we then find that this happens a lot, maybe at certain points, so this, of course, in this layout, this here is a problematic location, then we can consider the next step. Okay, do we have to take some additional measures in the simulation model? But also we always have to keep in mind how is this being treated in the real world? So there's no point in implementing something here in your model without knowing how the real world AGV would react to this situation. Right, but yeah, I definitely wanted to make this point that especially as a beginner, you should always start with the most simple approach and accept inaccuracies or not so pretty things in the animation, because that's not the main focus of why you should do a simulation study. It's always about the results, and you always have to take into account how much effort do you have to put in to create a certain outcome or animation, and what does that really give you in terms of analyzing your system and making decisions. Okay, so I see I'm already slightly over the rough time limit, but the last point should not take too much time, so I'll just rush through that one so that we have it all finished. A different kind of approach, which is again similar, so I'm allowing some collisions or driving through each other to happen, would be to not wait for a deadlock to happen and kind of sitting it out for 30 seconds, but to just accepting it from the start, from the get-go. So again, duplicate this AGV class here and call it slow down. And then I duplicate my model again, call it slow down. And again, go into this, again, back to the first distance control template, so like the basic code that we had. And I will rearrange it somewhat. So I will first keep this line. So how many AGVs are in my inner safety zone? And I will basically remove this whole first block, the rest of it. So I just ask how many AGVs are in my inner zone, how many are in my outer zone. And then I duplicate this code, this first code block where we slow down to 70% if somebody is in my outer safety zone. So I will just duplicate that and say, first check if there is anybody in my inner safety zone, I reduce my speed to, let's say, 20%. So this means, again, is in my inner safety zone. And then the rest I keep. So if there's nobody in my inner zone, but in my outer zone, I drive slowly, else I can drive full speed. So again, the main idea here is to say, I know, or assuming I know that the real world AGV has some autonomous capability of driving around a stopped AGV that is in the way, or to in intersection areas to kind of drive around each other, which takes more time because maybe they have to first stop and communicate, or drive slowly, or do rotating, or driving curve speed. So evading another AGV takes time. But again, usually there is no point in going through the immense effort of implementing this in detail when you do a simulation study. So instead, here I have assume I have an estimate and say if I run at 20% speed for that time, then that is approximately the additional time it takes to resolve that situation in the real world. So I put this here and then run it again. So now with this adjusted code, I do not wait in case of a deadlock situation for 30 seconds. I would immediately allow the AGVs to continue moving, but do so very slowly. So you see this here, right in the first situation here, my breakpoint triggers. So now this AGV was driving much slower while there was somebody else in the way, but they kept moving through the process. So again, the idea is to say this is possible in the real world. It takes additional time in these situations, but in the simulation model, this is usually sufficient to account for this additional time by driving slowly, by stopping for a few seconds, and usually it's not necessary to animate driving around each other, driving a curve, leaving the default path, which is of course possible, but even for an expert, you will spend a lot of time doing so. And I would argue there is very little benefit, except that you will end up with having a nicer animation or video for your management or for your customer, and that is usually not the benefit that is worth the amount of work that you have to put into it. So I would instead choose a time portion of your model where you don't have these ugly situations for taking your video, and resolving these situations in one or similar ways that I showed you here, which again I would argue are accurate enough usually for what you want to do. And also, again, as I said beforehand, this is a very basic session about this topic. So yeah, I hope we can do a follow-up session to talk about other ways of controlling or preventing collisions. But yeah, this was what I wanted to share with you from my side about these basic three kind of methods or approaches. And yeah, with that, I would say we can head into the Q&A session. Okay, I see a question in the chat. How can we visualize the safety zones? So if you're using the latest version 2404, then this is simply a matter of going into the 3D properties of your AGV and then going here to appearance and then checking this box, show safety zones. And then the safety zones that you have defined will be displayed and also scaled correctly. If you're using the older versions, you would have to create 3D graphics in your AGV class for the safety zones, and also if you need them to be flexible, you would also have to scale them accordingly. But in general, I would always say if you are working with free moving AGVs, you should always try to use the latest software version, because this is one of the features that are constantly being improved and evolved, and new features are added. So I would always encourage you to use the latest version if you work on with free moving AGVs.
Alexander, thank you first for your talk. Very interesting. I've been working with AGVs for a couple of months now, and I had the problem that when one AGV was standing and another was driving by, and the standing AGV was basically turning around, they started to call the control a couple of thousand times at a time, and the model was going really slow. How can I prevent that?
Well, I actually had ran into two issues when I created this specific layout here that I've also reported to GTAC, and I think one of them was also that the control was called too often. Usually, I would say if you still run into this kind of problem, something similar also used to happen with the track-bound AGV. So when you use the distance control for the track-bound AGV, so something similar could happen if you stop the AGV if somebody else is kind of too close, and then immediately the method would be called again to say, okay, now the other one is no longer too close. So then you start driving again. If you don't have acceleration, you would immediately be too close again, and then you could end up in similar situations. So I think probably a similar approach should work, that you don't stop or resume moving immediately, but give some additional time before you react and stop or slow down, or especially speed up again. I think we skipped Natalia's question that came in the chat before. So how many AGVs can run simultaneously, and how does the number affect performance? That is a difficult question, but definitely if you're using, difficult to answer in general, but if you're using this distance control mechanism, it is a lot of calculation that is running in the background, because you more or less have to continuously check if one of all the other AGVs really too close. We also ran a couple of months ago, I think, into a bug where AGVs on different height or Z positions still triggered the distance control. This has been fixed already. Benedict just also posted like he has 140 AGVs and it makes it significantly slower. That's definitely the case if you have a high number of AGVs that are, and again, we have the kind of the problem that one AGV in your whole model hierarchy in 3D, basically it has to check all the other AGVs, even if they're in completely different layout frames. I mean, I don't know exactly what is happening in the background, but technically it has to check all the other AGVs for being too close. So yeah, if you have a lot of AGVs, you will definitely see this impacting your runtime performance. I don't know how bad it gets because again, you can have other different other kind of models or large models that simply run slower because there's a lot of things to do. But yeah, so there would be other ways of preventing. So not basically not using the distance control mechanism, but using your own mechanism, which is something I would kind of talk about if we do a follow-up session, like we making reservations or announcing like to the markers where you are going, so that other AGVs know that they shouldn't go there yet. And this will remove the kind of overhead that is running in the background because you can limit the checks to only the situations that are actually relevant. But yeah, the distance control approach is very easy to get started, and as long as your model doesn't get too big, I think it works pretty well. But yeah, if you have too many AGVs, you may end up with a slow model. That's true. Okay, you also posted a question. I will look at it later to see what was in there. You also had the question: when is it useful to keep the if HV pool unequal to void kind of statement? So the default code that you have here, I think this should not really be relevant. If you work with a track-bound AGV class that drives on tracks and is not free-moving, so that is the distinction or the check that is being made here. So if AGV pool is void, it means that the AGV is like a forklift or some kind of track-bound AGV that moves on tracks. Then this whole safety zone concept isn't working like that. In that situations, you would use the older distance control, where you define a distance of 1 meter to the vehicle in front of you on the track in front of you. And then you would use this alternative parameter here, distances below limit, which tells you is someone closer than 1 meter to me or not. And normally you would have an HV class that is either free moving or track bound, because you can mix it somewhat. If you have a free moving HV, it can temporarily drive on tracks. But I think you would normally not really mix this. You would have either an HV class that is free moving or a transporter class that is track bound. So then it would be a different transporter class with its own method. And then again, there would be, I think, not really a point of in checking this, because this is the forklift class.
You should be seeing a screenshot of the forums that are located at Siemens.com Plant Simulation User Group. And so ultimately, that is where we post the recordings inside the forums for PLM. The screenshot that you're seeing is also a GIF, an animation showing that we recommend that you follow this area under this URL by clicking the follow button and then selecting every post under email notifications. And that just makes sure that you get an email when we post a new recording or when we post the registration link for the new topics. And as someone else mentioned, you can also ask questions. Stefan is there. You can mention him there. You can mention Alex there, or any of our other community catalysts. So, and also wanted to show what the topics are upcoming. So Alex is going to do another session with us on free moving AGVs, this time focusing on heat mapping. And so that will be our next session on March 12th. And then Stefan's going to do another Python session for us on March 26th. So this is accessing web apps, implant simulation using Python. So those are upcoming. The registration links will be posted at the URL that you see on your screen, which you can click on right now if you haven't been there. I would recommend click there, bookmark it, follow the topic if you haven't already. So we do still have a few more minutes before the hour is up. If you have a question, still time to raise your hand or to ask in the chat. But if for some reason you think of a question later on, you should see on the screen also Alex's contact in the community. You can click through there, his @mention, to get to his community profile in the forums. And then once again, there is a hyperlink to the forums where the page where the recording will be linked by Friday. So we'll have it posted there by Friday, and then also the registration link for his next AGV topic will be posted there too. So any final thoughts while we wait on a last question, Alex?
No, not from my side.
Yeah, I think that was pretty comprehensive. We're getting some hand claps, which is always great. Yeah, I see a Danke in the in the chat, which is good. So yeah, definitely appreciate you sharing your expertise with us and the community. So if there are no more questions, then we will see you all in the forums, and we will definitely see everyone on the next session on free driving AGVs. Okay.
Yeah, I hope to see you all there. Good.
All right. Thanks, everyone.
Bye,
Bye-bye.
everyone.